Aloha. This is a short guide on submitting jobs to the SLURM job scheduler on the HPC cluster. SLURM stands for Simple Linux Utility for Research Management. SLURM is the job scheduler for the cluster. SMatch and Srun are the two commands for requesting jobs from SLURM. SMatch submits a modified batch script with arguments and commands for the scheduler to use to schedule and run the job. Srun uses command line arguments to request resources for an interactive job, which you can use to test modules and programs on the fly. Let us start with the srun command. I just use the command srun space dash capital I 30 space dash p space sandbox space dash capital N space 1 space dash c lowercase space 1 space dash dash mem equals 6g space dash t space 0 dash 01 colon 00 colon 00 space dash dash pty space slash bin slash bash. Now, I know that's a lot to request a job, so let me go over what each argument means. Capital I 30 sets a timeout period of 30 seconds. So if the resources you requested are not available within 30 seconds, the command will automatically exit without giving you an interactive session. Default is 120 seconds. Dash P sandbox requests my job to be submitted on the sandbox partition. You will later learn the other names for partitions, but for now, sandbox is what we're using. Dash N1 requests a specific number of nodes, in this case 1. If omitted, the default is 1. Dash C1 requests for a specific number of cores per task, in this case 1. Also, if omitted, the default is 1. Dash dash mem equals 6g requests 6 gigabytes of memory to be allocated per node. If omitted, the default is 512 megabytes on a shared partition, and all memory on an exclusive partition. Always specify this if submitting jobs on non-exclusive partitions, because 512 megabytes memory will most likely not be enough to run anything useful. Dash T 0-01 colon 00 colon 00 shows how much time you are requesting in the days hours minutes seconds format. In this case, I'm requesting 1 hour. Alternatively, you may just use the number of minutes, like dash T space 60, for an hour. And finally, dash dash pty slash bin slash bash tells the scheduler what initial task to execute in sudo terminal mode. In this case, it opens a bash shell for me to test anything I want on the compute nodes. As you can see, now I have been assigned to node 001, and I am running on this node with the resources I requested for the hour. After the hour, I will be kicked off by SLURM. I can now compile programs or do test runs to make sure everything is working and confirm which modules I need to load on my SMatch script. Next, I'll show you how to use the SMatch command. For SMatch, it is important to remember that the script will use the current working directory of the shell as the working directory of the script. So if you're using the script with relative paths, you should always run the SMatch command from the script's directory. Before I submit this example script, let's take a look at it. These submission scripts are shell scripts in which lines commented out by $, are taken as directives for the job scheduler, and lines commented out by $, are ignored by the scheduler completely. Each line is its own argument. The first line, $, exclamation point, /bin, /bash, points the scheduler to the shell that the script is to be run in. All the following lines, starting with $SMatch, are each followed by the long-form arguments for the scheduler, like memory, nodes, or cores for your job, just like the short-form versions I discussed for Srun. For more information on possible arguments, check the link in the description below. You can use the script as a template for your non-MPI jobs. After the commented lines, it is just a simple bash script that sources your bash profile and runs the script build.sh, which loads modules and runs make, and then it runs the executable hello with a random number as an argument. Now let's run the script. The command tells me that I have submitted batch job 101022907. I should note down this number as it can be used to check the status, or if something goes wrong, you can use it to troubleshoot. After a while, you should see the hello executable compile into the directory, and then you can check the output to verify it is working properly. And that's how you submit jobs to the cluster using SMatch. If you want to cancel a submitted job, use the scancel command, followed by the job ID that you received when you submitted the job. If you don't have the job ID saved, you can always use the SACCT command to see the details for active or completed jobs. The sinfo command shows the state of the partitions on the cluster and node membership. And the sq command reports on the state of jobs or job steps currently existing on the cluster. With the sq command, the state shows R for running and PD for pending. The current runtime if the job is running with days-hours, minutes, seconds time format. In addition to the basic arguments for job submissions, here are a few I want to cover. By default, every node has one core reserved for the operating system. Tests have shown that this is optimal for most jobs. If you request one node and get assigned a 20-core node, your job will only run on 19 cores. However, you can turn this reservation off by using the --core-spec equals 0 argument. In some cases, users may find through testing that using all the cores on a node shows no degradation in performance. The user is able to override the one-core reservation and utilize all cores on the node. Please note that this option should only be used when submitting on an exclusive partition, as it only makes sense if the user is trying to reserve an entire node. Two other important arguments are used to request specific hardware. The --constraint command takes a string in double quotes, where each constraint is separated by an ampersand for and a vertical line pipe for or. For example, the --constraint equals x86 and IBQDR argument would have SLURM only assign nodes that are on the InfiniBand QDR interconnect and are using the Intel x86 architecture. The --grez constraint takes a comma delimited list of generic consumable resources which a job should be granted access to. Currently, on the HPC, this command applies to graphics cards. Each resource follows the format type, description, count. So the --grez equals GPU, NV-RTX 2080 Ti, 8 argument, we request a node that has 8 RTX 2080 Ti GPUs. For a comprehensive list of job submission arguments as well as current constraints and grez descriptions that can be requested, please see the links in the description below. If you want to know more about partitions you can submit to, please see our next video on partitions. Mahalo.